Good morning.
Good morning.
Morning. All right, Danny, I have a question.
Okay.
What 3D prints do you have that make good gift ideas?
Oh, geez.
What's your
Um,
that's top 5 favorite 3D print ideas that make good gifts?
what they called? I do pictures.
Pictures.
There's a way you can. There's a program. I'm trying to remember the name of it. You take a photograph, right?
Okay.
And you load it into this program, and what it does is it does it takes the photograph and turns it lithograph. It turns it into a lithograph, which you 3D print, and if you hold it up to the light, you see the picture because it varies the thickness of the print,
Yeah.
so it varies the opacity. And hang on, see if I can find one. I have one around here somewhere that I can show you. Give me a second. It's really going to be hard to see because you have to hold it up to the light to see it. I can maybe use my phone to, I don't know. So this is what it looks like, and this one's curved, so it stands up on its own. But if you
Interesting.
hold I usually set them, I can do them flat and you put them in the window. If you put the light behind it, it's not going to show up well on the
Yeah,
camera.
it's you have that blurred thing on. You gotta take that off.
Yeah, hang on.
Otherwise, it doesn't focus on things that are close.
Even that,
Yeah, even then.
it's not seeing
The
I can
textures.
see it really well. It's just seeing the light. But anyway, it really, you have to actually see it in person to get it. But it's a when you put it in light, you can. I mean, it looks like a real black and white photograph. I mean, and it's very, very detailed.
And totally customized to like whatever picture it is.
Well, you somebody like I do it for friends, and they'll download a picture for me, or they'll just send me like one of their favorite pictures, a photograph or a picture they took on their phone, and you do this litho. There's a program I found. It's called It's Litho, I think is the name of the program. And it converts the photograph into the into the lithograph. And then you can bring, that's one of my favorite gift ideas. I just shipped my son a dice tower.
Oh, really?
Yeah, I made him a dice tower for, he plays a lot of Dungeons and Dragons.
Yeah.
So I got some really cool filament that was like kind of a bronzy, black bronze blend.
Uh-huh.
And let me see if I can show him. I'm gonna
Where you got the dice tower from?
I just downloaded it off of a GitHub, or actually Thingiverse is another one. It's
Yeah, I've been looking at Thingiverse, but
Thingiverse has a lot. GrabCAD has some cool stuff. If I can find a picture of the dice tower I printed. Yeah. I'll just hold the camera. See if you can see the. It's kind of hard. Let's see if I can send it. It's on my phone. I can email it to myself.
I'm sure there's tons of D&D miniatures you can make too.
Oh my God, yes. In fact, one of my friends, I had two resin printers that somebody gotten from a grant, and I never use them. So what I did was I loaned them to a friend of mine, another teacher at the school. and he's gonna, I think he's an English teacher. And he is going to use them to print, figures from the stories and stuff, miniatures.
I guess resin's really good for doing that.
Resin is different.
Because I was thinking stuff like a sword sticking straight up, like that's not gonna work well with, let's say, regular
Well,
PLA.
Yeah, and that's kind of what we're talking about today in our project. When we talk about the project, is one of the things with designing things that are going to be printed is you have to understand the limitations of 3D printing
And the materials, yeah.
and the material that you're using.
So is the resin a little more like flexible, like forgiving
Oh,
kind
no,
of?
no, no. Resin is more like hard candy. It's very
Oh,
brittle, but
really?
you get very fine details with it.
I see.
And there are there's no layer adhesion, there's no layer lines or anything like that.
So I was looking, what's the other ABS? So I was looking at ABS and I was
And
reading.
the thing is, resin prints totally differently with using a totally different method than like fuse deposition is the way most 3D printers work. Resin printers use I can't remember but they use they print upside down, and they do a whole layer at one time using light to harden the resin in a specific pattern. So it's really kind of interesting to watch, but it's very messy. It involves several steps and chemicals that might be dangerous for some students to be around. So you got to be careful with it.
So yeah, the ABS, I was looking, like if you wanted something like smooth, you just apply a little acetone or put in an acetone bath and it just like smooths and make the whole thing shiny.
Yeah, you can do a lot. Like I've tried things where you take a 3D print and you put it in an oven, and
Oh, it kind of melts it a little.
it kind of melts it a little bit and blends it. You got to be very careful. Or a
Yeah, I
heat
can
gun.
imagine the heat has to be precise in the timing.
Yeah, it's something you can play around with. A heat gun is something else that
I could see that.
that can help. But using brushing acetone. Let's see, I just downloaded this picture. There it is. Why is my okay? So I don't know if you can see that. That's the dice
Oh, that's
tower.
awesome. Yeah.
Yeah, so I made that. In fact, I just mailed it to him yesterday because his birthday.
Did that print in 2 pieces? I mean,
No, that's a single. That's a
it's
single
a
piece
single
right
print.
there. It
Oh
took
man,
like
that's
3
awesome.
days.
Oh, my printer would have
Yeah.
so messed up in those 3 days.
Well, I printed it on an Ender 5.
Really?
Yes.
Wow. Yeah, I like the coloration, that kind of like how it's yeah, it's not the same color
And
throughout. It's kind of
that was just the filament that I bought.
Can you email me that file?
It's not on this computer.
Yeah.
It's on my laptop.
Maybe you
But
said
I
you got off
can
of
if I remember.
Thingiverse though.
I'm pretty sure I got that from Thingiverse.
That's really cool.
And it's a one print, one piece tower, which
And you did
came out with-
nothing else to it. That's just how it printed.
That's exactly how it printed.
Wow, that was
Yes.
great. That's great.
And so like I said, a lot of what you print depends on the filament that you use. And you can try, there's some really, really neat color changing filaments out there.
I've seen some. They even glow in the dark filaments.
Yes, there are. So that's one of the things we're going to talk about today, the final project. Does anybody have any questions about yesterday's stuff? No, I know it was a lot. And it's just going to be a matter. And I think what's going to happen is when we start on the practice test, you guys are going to see some of that stuff and how it's presented. And you probably have some more questions, a lot more questions. So what I want to do today is, I know on the schedule, it says we're going to talk about this final project all day, but there's really nothing a lot to talk about other than the fact that all this stuff is here. And if you get to that, it's wonderful. I have never done this project personally. I
Wow,
know
yeah.
this
So
is,
you've never gotten to the final project?
no, I mean, I did a modified version of it. So let's see, not this past year, but the year before, I had a group come in from LSU, from the engineering department, and do a cooperative 3D printing workshop with me. So
Yeah.
in lieu of the final project, we kind of had to modify it. So one of the teachers brought some of their grad students in, and they gave a big lecture on 3D printing. They demonstrated the different 3D printers, and we did a modified project on this. And then they came back towards the end and helped the kids print their projects. And then that's how I got my resin printers, and I got a dual extrusion printer from LSU. So I've done a modified version of it. And so what I do now is, since of my testing, what I'll do is I'll let students work on the project while or if they finish with their test, they can do the project. And the key for the project for me is they get to design something that they can 3D print, a large object, and
By
so,
large, how large are we talking?
well, one group last year made a sword that consisted of 5 different parts, and when you put them all together, it's about 3.5 feet long.
Yeah, it's
And
large.
the hilt was about 10 inches wide, and so that's something that one group did. Another group did a Yahtzee set. So there are your things, your slide decks in here that talk about working as a team.
How many members did you have per group?
Usually about 3, because that's how it was on my tables.
Yeah, okay. I was
So
just trying to think of how many 3D printers I'll have to do to work on such a project.
well, that's the thing is, you got to schedule the time on the 3D prints, and you might want to look at putting limits on how large of objects. This is a unit that you need to go through and look at and kind of model to your needs, is all I could say. If you look at this, so in here is a solution on 3D printing. Then we talk about patents, and we talk about the problem statement. So this is all of what, and remember, this is modeled off of the CM 1020 class that they teach to college students at LSU for construction management. So it's a little more, this is, college level. And I don't know what level you teach, but I teach mostly like sophomores and juniors, which I'm not saying they can't do it, because they can. But if you look at the timeline, you're looking at something that could conceivably take, even if you do 1, 2, 3, 4, 5, 6, 7, 8, 9, that could take 9 class periods. And 9 class periods for me is almost 4 weeks, because I do 5 class periods per 2 weeks. And if there's any kind of, at the end of the year, you've got testing and you've got all this other stuff that's going to break you up. So it's a large, this is designed to cover a whole 6-week period.
Well, I'm gonna have to ask, why is it in here if it's too big and we can't cover it and the test is the most important thing?
That's a Vanessa question.
Yeah.
I think it's in here because ideally, in an ideal situation, we would get to this. And I have, like I said, I have done a modified version of it. And I think it's something really cool for the students to do. And this course is also being adapted from the college version. So
It just
this
seems
is
like
something
it seems
that
like
can
Vanessa's trying to
change.
do too much with the course.
Well, I don't think that's the key. I think it's kind of a, okay, here's an example. I taught, when I first taught in the LSU pathways, I taught ICT, which if you guys aren't familiar with it, that's Introduction to Computational Thinking.
Mhm.
And it's a like a programming class that has a lot of math standards in it. It's now that course has been around for about 6 years, I think, 5 or 6
It's
years.
been a while, yes.
It changes every year. Like the first year I taught it, the curriculum that I taught was totally different from the guys, not totally different, but significantly different as far as rearranging. So with the LSU pathways, they are constantly rearranging and adapting the course to fit the needs of the teachers. And if something doesn't work one way, then they'll probably change it to see that it adapts.
Yeah, it's
Um,
I understand it's like it's an iterative process, but still.
and I think this project is an ideal, and a lot of these things are in an ideal situation. This is what you would do. My
I noticed
situation,
that some years my students just do better than other years.
oh yeah. So in
It's
one
really
year,
weird.
like
But
you'll
sometimes you
have
get a
kids that
good
just
crop of
breeze through.
students. Like it
Yeah,
really is.
and you
Like
can get
just like
further.
farming. Sometimes you use the same soil, the same seeds, the same fertilizer. Your crop is different. You can't account
Right.
for every variable, you know?
So in an ideal situation, you would get to this your last 6 weeks. And this is also something that can be done in conjunction with testing. So like at the end of the year, you have a lot of your schedule jumps around a lot. And my situation is different from a lot of teachers. When I say I've never got, that's because I miss a lot of school during the spring. And that's because of my robotics competitions. Like I said, I missed like 12 days of class in March and April. And
Are you
and
year
that's,
long or are y'all semester?
we're year long,
Okay.
but we're AB block. So for example, if I have a class, if I have a class where I see on a Tuesday or like on a Monday, let's say I see that class on Monday, and then Tuesday I see a different set of classes, and then Wednesday, Thursday, Friday I'm out for a competition. I come back and I won't see that Monday class again until the next Tuesday. So it's going to be like a week and a day between when I see this one class, you know. So, and if you have it set up right, they can work on this stuff when you're not there as a sub work, or they can be studying for their test, or a combination of the two. So it's not and there are teachers who actually do teach this
Okay.
this project. So it's not like it's impossible. It's in a good situation. And I'm just telling you my personal situation, but there are other teachers who do get to do the final project. But all I'm saying is that you need to you can modify it to fit your needs, I guess is what I'm trying to get at. And some of this stuff could be done if you have a long class, 90-minute class periods. And my other situation is, even though I'm on a block schedule where I should be having 90-minute classes every day, because of the way the STEM Center works, the students are bussed over from the high school. So that takes off 12 minutes at the beginning and 12 minutes at the end of each class. So instead of having 90-minute classes, I only have 65-minute classes. So that reduces my class time as well. So, you know, but if you have a normal 90-minute class block, you can do a lot more. So I'm trying to cram 90-minute lessons into 65 minutes, basically. So it's my situation, like I said, is kind of unique. But I do know other teachers who have done this and they do it well. So this is basically your project timeline, and it goes through what you want them to do and when you want them to do it. And there are several, each one, they have a presentation of their problem statement. So if we look at the overview, let me see, go back here. Statement. Okay, so this is kind of like an overview of the project and what it's all about. So, you know, you can read this. And so basically you want the students to do, to come up with a idea to solve a potential problem. Okay. And in a nutshell, you want them to identify a problem, come up with solutions of creating an object. And the object has to have at least 3 3D printed parts per team member. So if you have, you know, 3 members on a team, that's 6 different 3D printed parts. That in itself could cause a problem, you know, as far as just printing time. If you only have 1 printer, it's going to be almost impossible to print that many different parts, depending on the number of students you have. So at that point, you would say, okay, we want to limit the size of the parts or something. And so they're going to come up with, they're going to come up with a problem. They're going to come up with a solution. And once again, at this point, what I've done in the past is I've adapted this and said, okay, let's go ahead and look up something online that might have an idea. Like there was an automatic cat feeder or an automatic dog feeder that one group did one year. And so what they did was they looked at a bunch of different ideas and then they designed their own using the 3D printed parts. And there's actually a couple of them that you can pull in the Arduinos and automate it if you, you know, with a timer, a simple timing system and a motor. You give them, this one gives them a budget. But once again, that depends on your class budget, if you have allotment funds or not. You know, I get a good allotment per year. So I can afford to buy stuff that the kids want to use for their projects. Other stuff, you know, depending on your budget. And then they create a little presentation. So the first thing they do is they decide on the project they're going to solve, and how they're going to print their object or create their objects and create a solution. You know, so you can read through this and go through it. And this is a resource, guys. And I do stress the fact that even though I said that I don't ever get to, some people do. And you can go through this and read over it and adapt it and do what you want. So that, and then there's the problem statement. Then there's the expectations. This is where you go through at the beginning and tell them what all you want. This is a short kind of overview on 3D printing. The problem with doing a class, we used to have a unit on 3D printing. The problem with doing the unit on 3D printing is that all 3D printers are different. They're structured differently. They have different pros and cons. They use different programs as slicer programs, depending on which one you use. So it's really hard to to have a structured lesson other than the fact that, okay, this is what 3D printing does. This is an example of 3D printing. So you can do the basics, and there's some really good videos and stuff in there. And depending on, you know, how well you are or how knowledgeable you are. I have some students in my class that know way more about 3D printing than I do. And I consider, you know, I'm not an expert by any means, but I'm fairly knowledgeable on 3D printing. But I have some students who, you know, they've had 3D printers since they were in 8th grade, and they print stuff all the time. They watch hundreds of videos, and they can tell me things. And I always go to, hey, Jojo, what do I do about this? I have one student whose parents own a company that's a 3D printing service. So they probably got 20 3D printers at their business. And so I'm always talking to Jojo about, you know, hey, what do I do about this? Or what have you done about this? Or, you know, what do you think about this? So, you know, use your students as a resource too, because some of them will know more about that than you. So then it takes the project through the identifying a problem, the researching and brainstorming. You have different things about talking about Gantt charts and you know, project management and you know, a lot of this stuff. And then designing and testing the product, and then your final documentation. So once again, I would suggest that you read through all of this and see what you can do as you get towards the end of your first year. It would be nice to do some sort of end of the year project. It doesn't have to be exactly like this, but these are the resources that you can use to help that out. And once again, it's going to depend on your testing situation. So my first year, like I told you guys, I didn't even get my Inventor installed on my computers till like December. So I was way behind, and there was no chance I would ever get to this. And then the second year I did the co-op with LSU. And so we kind of did a little bit of this. And last year we made it to Worlds, and I wasn't even there. And and then they cut our year a week short because of some political stuff. So it was total mayhem at the end of last year. So I did not do it at all. But so it's there for you to adapt to and do what you can. The kids really enjoy the 3D printing and the getting the objects and being able to take something and say, I did this. And you know, I have some of the prints just sitting around the classroom, and they'll come visit and they'll say, oh, look, I made this. And they really love it. So this is something that you really want to, it should be your goal to do the project if possible. And that just depends on your certification. That's really all I want to talk about that for today. If you go through this stuff and you have questions, yeah, we can talk about that. And I'll talk, you know, if you have questions about 3D printing at any time throughout the year, just email me or Vanessa. But if it's a 3D printing question, Vanessa's probably just going to forward it to me. So, but yeah. All right. But what I want to do, so for the rest of today, to kind of help you guys out, there is under exams, we're going to go ahead and let you take your first inventor practice test. Okay. Just so that you can get an eye and understand what it's like. Okay. So now in order to take the practice test, you need all of these files that are in the folder. Okay. So if you didn't see where I went, it's in the main Google Drive under exams, EDD, and then inventor exams. And then there's this big thing that says files to download to practice test 1 and 2. So what you should do is you should take this folder. You want to download the entire folder. Okay, it might take a little while because it's got a lot of files in it. Oh, wow. Well, I do have fiber here, but. And then once you do it, you want to make sure that you save that into your inventor. Where to go, documents. You want to save that into your inventor, and I would go ahead and just make a file for it, call it practice test files or something like that. And then, okay, so did I just download? Okay. Extract all, and I'm going to extract them to my practice test files. Actually, you don't have to make a new folder. It comes with the folder itself. So, okay. So let me know when you guys have accomplished that wonderful task. All right. How you guys doing? You getting it downloaded?
Got him.
Gary, okay, good. Now, in the practice test folder, and this is something I've done in the past. So when I taught this before I started teaching the LSU curriculum, I kind of invented my own curriculum. And one of the things I did was I took the geometrics practice problems, and those were my bell works every day. So every day we would go through a practice problem. But this course has its own different sets of bell works. So I don't really usually do that with this class. Now, but once you get towards the end of the year and you're starting to review for the test, you can do that. So once you have everything downloaded, we're going to go under where it says under inventor exams. And then practice test 1 metrics. And the first thing, it's a Google form. It's a Google test. All right. So now here, you're going to go through here, and if you just do your test, you read all the instructions, what period, just put 1. And then you're going to go through, and I'll show you an example of how this works. So this is the test. So you're going to go to, ignore the part where it says data files, because that's where Gmetrics loads the files. You're going to go to wherever you downloaded the files, and you're going to open viewcube.ipt. And then you're gonna rotate it around and you're gonna try to get the length of the longest line. And then you're gonna put your answer. Normally you would put your answer there, but on this, you're gonna put your answer there. And oh, it shows the correct answer. Why is it showing you the correct answer? Is that just for me?
I don't know, but I like this test already.
What is a practice test? So the thing is, maybe it's set to show the answers. I don't know. I'll have to look at that.
It's not showing them on my end,
Maybe it's just because I have admin rights. Okay,
probably.
so here's the thing. This is a practice test, but if you have questions during the test, ask. You know, this is kind of just to help you out. At a later date, if you want to go through and do it on your own, there's also there's a practice test too. And when you get to geometrics at your school, you'll notice that there's a couple of different practice tests that you can take with different sets of problems. So what I want you to do is I want you to start working through this practice test. And I will answer questions at any point. Don't think that you have to actually, because this is practice. It's not an actual test. So if at any point you get totally stumped, then ask, okay? Anybody have any questions? Did everybody get the files downloaded?
Yes.
Yes. Okay.
Yes.
All right. So and this is what I want to do. So tomorrow we have like some surveys and your post test and some other housekeeping things. So, which is why I wanted y'all to start on this today so that tomorrow we can have some more time to go over this if we have a lot of questions. Okay.
Okay.
All right. Knock yourselves out. Get busy.
Hey, I'm trying to do a sweep and it won't work. But if I do it myself, it works. You're muted.
You're talking about using the sweep IPT part that they provide?
Yeah, on the homework too, I couldn't do it on the one provided, but if I draw one, it works.
All right, well, let me see your screen. Can you share your screen?
Got it?
Okay. That's the sweep, yeah, sweep IPT, okay. So go ahead and hit the sweep function.
And it's pre-selected. That's how the other one was.
Right.
It's-
And
I mean, I've tried removing, like you can
do
go
the
up
other
here and
option under orientation and see what happens. Yeah, that one works. So that one, do that one.
okay.
All right.
Thank
And
you.
I think that should give you the right answer. What answer are you getting
Okay.
right there? If you get the, what they ask for the area?
Yeah. Yeah. What's this changing?
It's changing the orientation of the profile as it goes along the path.
So it was trying to go
In,
that way?
in the first option, the profile is gonna remain perpendicular to the path as it travels around. Okay,
Uh-huh.
and the other one, the profile is gonna remain fixed orientation. So if it's vertical, as it sweeps down the path, the profile is gonna remain vertical. The other
Okay.
one, the profile will tilt to remain perpendicular to the path.
Yeah, you would think that would be.
In the actual, let me see, does it say in the actual,
Question.
question whether you do, what
Okay.
the,
I don't think so.
let me look real quick.
We'll have it up.
Danny, I got a question about 12 because I can't see the dimensions in the picture.
All right, hang on a second.
Okay.
What'd you get for the answer of that?
I didn't get the area yet.
All right, when you get the area, let me know.
Okay. Let me stop sharing.
And what are you asking for, number 12?
Yes, sir. They give a picture for putting this bridge in, but those dimensions, like it's just pixels almost.
All right. Probably because, trying to zoom in and, yeah, I see what you're saying. So here's the thing.
Yes, sir.
It doesn't matter. I'm pretty sure. Let me look back at the, and this is kind of what you'll find out is that
Yeah, it doesn't
They tell
matter.
you
I'm
to-
looking at the question. You're right.
it doesn't matter how far it is from the side. They're just wanting to know the surface area of that part. And if you make it 0.5 wide,
It won't matter. You're right.
right. So,
Never
and a
mind.
lot of my students will come say, well, coach, even if I do it like this, I still get the same answer. I'm like, you're right. You
Yeah.
know, at some point, all they're looking for is the surface of that rectangle. And you know, it doesn't matter if you put it 1 inch from the edge or 5 inches from the edge, you're gonna get the same answer.
Gotcha. Thank you.
On the test, you'd be able to see that. This is just because they copied the answer from the picture from the practice test and made it smaller, of course. Kathy, did you get an answer for that sweep? I can do it real quick. Back on. It's not gonna get you the right answer.
Um, 1.859.
I think that's it. Yep. That I believe is the proper answer.
Okay,
Yep.
thank you.
That is the proper answer.
Okay.
Question on that one. It's asking for surface area.
Correct.
Wouldn't area be the area of the entire inside of the cylinder, or does the sweep just do a surface area?
The sweep is a solid cylinder.
So if it's
In
asking
this
for,
case, the sweep is a solid object.
so if it is area this, why would area be the same as surface area then?
What do you mean?
Exactly what I asked. In the properties, it gives area. But that you're saying that's the same as surface area?
That is, yeah, in the properties, yeah, the area means surface area, my bad.
Oh, so it
But
doesn't
what
mean the
happens is-
actual area?
Oh, it's surface area. What do you mean the area?
I guess I'm thinking of volume, not really area.
Right. So the actual, so
Okay.
what sometimes the people do to get this wrong though, is they will use, I'm gonna share real quick. What you wanna be careful here is what sometimes the students will do is they'll go to the tools and they'll go measure and they'll click on the tube right there
Mhm.
and look at the area as 1.760. Well, that's not the right answer because it
It didn't
doesn't
include the
the-
ends. I see the two circles.
Right. So that's, you got to be careful that they do the properties thing. And if you have students that keep getting that wrong, make sure they're using it, the entire area, using the I properties.
Gotcha.
Yeah, I don't know why they don't put surface area there. They just put area, but they mean surface area.
Question. Hey, you're muted.
Yes, sir.
On number 6, says open project center lines at WDG. Should it look like this drawing?
Hang on. Let me see, it should.
Because when I opened, so I did this one, it didn't look like the drawing, and I still try to do it. And when I opened up number 7, plate.wdg, well, center lines WDG is basically the same thing as plate.wdg. It's like the same object.
I'm not seeing that as the same object. Which one are you supposed to be opening?
Centerlines.wdg.
Okay, I'm sorry, I'm looking at different. It may actually be the same object,
Okay,
but
then
it
look,
asks you
that's
to do
very
different.
very
different
misleading that
things.
the two are the same object and that this one has a different drawing. It makes me
Well,
believe that it's
They
not.
just may be asking you to do different things to it. So center line.
But then on plate WDG, it does show you the proper drawing, and centerlines WDG does not. This makes me believe that this is
All right,
not the right
hang on.
one.
It might not be. Just give me a second to look at it. Okay. So if you look at the question and read it, this is project centerlines.dwg, not centerlines.dwg.
I see.
It's a different file. You're looking at the wrong file.
All right.
Or project, actually, it's project centerlines. A lot of times the files give you kind of a hint as to what you're supposed to, the name of the file gives you a hint as to what you're supposed to do. And the funny thing is what's funny about that question is that's another one of those where you really don't even have to do what they tell you to do to get the right answer.
Yeah, I quickly figured that out.
Yeah, so, and the kids will figure that out too. Sometimes it's kind of silly like that. All right, just checking in. How you guys doing?
Finished about 25 minutes ago. I'm going over my results, seeing where I screwed up.
Oh, you got the answers? You checked the answers in the,
Well, put it this way, I'm going over what it says I did wrong, so I went back and redid all the problems just to kind of
Okay.
see what mistakes I made. One of them, number one, I typed probably the right answer, but I gave the decimals and I shouldn't have, at least from what I'm reading by where it says type your answer, and it's got 3 number symbols, and I gave it 3 numbers and 3 places behind the decimal it didn't need.
you got to be careful that your format of your answer matches what they asked for.
Then number 2, the minor grid display. I think I know what I did wrong. I had no clue what a minor grid display was. I just
That is, you know, that question's been on there and I've never actually seen anybody need to do that. It's very, very simple.
now that I got it wrong, I'm pretty sure it is simple. I hadn't looked at the actual
It's,
answers
but
yet.
it's something that's really simple, but it's really misleading for a lot of students, the way they ask it. And a lot of kids miss it, but when you go back and show them, they're like, oh my God, you know, it's, if you go, am I sharing you? No. If you're an inventor, if you open any part, it doesn't matter what part it is. In fact, wait, I think I actually have that one open because it's view management, right?
Yes.
It's the open, the part has absolutely nothing to do with it. You go to view and you go to, was this the ground plane or the minor? Yeah. You go to
Ground plane, minor grid display.
and you go to settings. And where it says minor grid display, the base is 20 millimeters. They ask you to add 10 to that, right?
Yep.
So the answer is
Should be 30.
millimeters. So a lot of kids will see that and they'll just read the 20 and they'll put that, but they ask you to actually add 10 to it, so the answer would be 30 millimeters.
Yeah, I thought they wanted me to go back to 0 and add 10, so.
Right, and see, that's
Overthought
the
it.
other thing is the base is 20. 20 is the default, and if you add 10,
That's
then
30.
it's 30, right? It's so that's the whole thing is people, you know, it's kind of misleading. Just one of those things. It's one of those things where you can change your view environment. I don't know. I'm sure people use that at some point for presentations and stuff, but at the moment, it's not that. I've never actually had to use that in real life. So
Then with
of
number,
course, I don't do a lot of stuff.
then with number
Yeah.
3, I got it wrong, the sweep thing, and I think I know what I did wrong there. So I went back and took the area, the 2 circles on each end, added them back up. I still hadn't checked the answer, so I don't know if what I did is.
Well,
To fix
and
it
that's
if it's right.
we talked about that a minute ago. I don't know if you were listening to that conversation, but so what you have to do for this is, and this is something that the students are going to do as well. If I use tools measure to get the surface area, it's just going to give me the round part, not the 2 end parts, right?
Yeah, and I put in the answer, the round part, and got it wrong.
Right. So what you have to do is, because when you use this, it's just going to measure whatever surface you click on. But if you actually go to your properties, your eye properties, and go to physical, it shows you the area right there. That's the entire object.
1.858 or 9.
9.
Okay, because I did it by math, I measured the 2 circles on each end. Or I
Oh, and then you
measured
added them
one
together?
and added up, yeah.
That'll work. What'd you get?
Well, when I did it with that, it came out to 1.858, not 1.859.
So there might have been some rounding.
Yep,
Yeah, because I tell my kids all the time, I said, there's old t-shirt says 2 + 2 = 5 for really large values of 2,
yeah,
which is, and I explained to them how it's technically possible if you're using if you're using significant digits and you're only showing one digit, you could actually have 2.4 plus 2.4, which each would show up as 2. But when you add them together, they equal 4.8, which would be rounded to 5. So if you're using a system that only shows one decimal place or one digit, even though the value is 2.4, it's only going to show up on the screen as 2. And then when you add them together, you get 5.
yeah.
So, that's the issue with trying to do it by hand, is that sometimes you encounter these rounding errors. So you always want to stress that if we're talking about the whole object, we should always use either the regular thing and go to eye properties, or the solid bodies, click on the solid and go to properties, update, and get the answer of the area from there, because this is the entire object.
Gotcha.
And we only use the measure tool if we're looking at a particular surface of the object.
Four, probably because I don't understand what grip length was. I measured it one way, I measured it the second way. Like I said, I hadn't actually pulled up the correct answers yet to check. I just went back to see if I could find
Yeah.
different stuff.
I got that one wrong because I thought of grip length as the length that included the threads, not that little part of the end that can't grip.
Let me look at it.
I wish it would just said what's the length of the remaining bolt instead of grip length.
Yeah, I think it does remaining bolt, but there's a little parentheses, bolt sticking out right there.
Well, I measured it one way, which was from the very bottom of that nut to the very tip of the bolt there. Put that in, it didn't like that, so I measured a different way, found something a little smaller, but I hadn't checked to see which one's
Well,
right.
And this is another one of those that's very finicky. Assembly constraints, okay. Sorry.
Bring this where it's-
So when you do this, and this is the exact same one we were doing yesterday. You got to be very careful where you click to do your constraints. So you're going to use insert. On not this circle, not that circle. Okay, so this outer circle, not the small circle on the inside. So you click that one. And then on here, you click, oh, yeah,
No,
that one.
I got all that perfectly fine. It was I measured just the threading and not, I measured the
And
threading.
then when
'cause it
you
said
measure,
grip.
that's another thing that can be weird. Is when you go to your measure, you got to be careful that you measure like that surface to, I think there was another one in there. And that's 0.787. What will happen here is some of the things that kids will do wrong is they'll measure from like a point up here.
Wait, 0.787 is supposed to be correct?
Yeah.
That's what I
Yeah.
put on the test and it says it's wrong.
Oh,
Oh,
let me look.
this is another thing. Do you have to include units on the test?
Generally not.
Okay, because I've been typing in units because it
Yeah,
says
'cause when
answer
you
and then it
look-
has numbers and then it says inches. So I've been typing in the numbers and space inches.
No, you don't put inches. You only put in what's missing, like where the hashtags are.
I got you.
So Yeah, 0.787.
So you gotta put the 0.
You see,
Yeah,
and
because
that's,
it's included in the number.
if you look at the hashtags, you gotta, it's gotta be 0.787.
On the
And-
real test, will those hashtags be there to tell you how many digits?
Yes.
Okay.
As far as I remember, yes,
Okay.
unless they've changed it. I've been downloading some stuff. Let's see if it's on my desktop now. And I want to see if this is the same practice test. I just downloaded this from a different website from a publisher that I used a lot of their books as resources. I think they're really good. In fact, when I had to create my own class, I used this books from this publisher. But I know LSU wanted to create their own content. That's why we don't generally talk about it. But I'm looking at this. I don't know why. Anyway, if I get it up, I'll share it with y'all. If it comes up, if it works. Seems to be loaded, but if you have any more questions, yeah, keep asking, because this is good. Because these are all things students are going to experience and that you need to, be familiar with. And these are all questions that you guys are asking. These are all questions that I've gotten from my students.
"13, open pattern. And it says create a view representation of the current view. That I had no clue.
Yeah, once again, this is something that I've not encountered before. And something that when the kids take it, if they come back and ask, I'll go, oh, yeah, this is,
Yeah, I skipped 2 and 13.
I can show what I did. I got an answer of shaded with edges. That's what I put. I don't know if that's anywhere
No.
near right.
No, because they're asking you create a view representation of the current view. A view has already been created. Use the next default. But then they say, what is the default name for this view? Okay. So once again, it's got nothing to do with the part. Okay.
Okay.
So any part, let's go back. I'll go ahead and open it. What's the name of the part for that one?
Pattern.
Pattern?
Pattern. Number 13 says open pattern dot IPT.
Okay. All right. And then it says right here where it says view.
Okay.
All right. You go new. What is it? View 2. View 1 is the default. View 2 is the second default.
Okay. See, I thought it was something up in the toolbar view, and I went to visual style, and I thought that's what we were going.
No, it's, and then see, that's the thing is, I've never used this in reality. I don't know. Honestly, I can't even tell you what they would use that, why you would use that.
Okay.
I've never encountered it.
View 2 makes sense.
If I ever do encounter it in a practical setting, I'll be sure to know how and why. Yeah, view 2 is the correct answer. And it's no space in between the word view and the number 2. So if you look here, see, it's view 1 is the default original view. And then when you add a new view, it's just view 2. And once again, if you double click on either one, they're both the same. So if I ever encounter that in the real world, I might, try to look that up and see what that's actually used for. But I'm totally clueless, and I apologize for that. I guess I
Okay.
need to look that up, huh? Look that up while y'all are doing y'all stuff. Oh, okay, I guess I can see how that would be. I'm doing some research on it. Okay, so that's kind of neat. So let's say you're in hang on, let me let's say you have a part, and as you're working on that part, you want to sometimes look at the half section view. And so if I change something, how does that view change? Well, instead of having to go through every time and go to the, create the half section view, I can just define another view as the half section view of the part. So as I'm working, I can just quickly alter between the full section view and the half section view. And so even if I add parts, let's just say I don't think that would actually show up. Should have 8. Yeah. Okay. Then I switch to view 2. You can see that all of the adjustments show up on the half section view as well. So I guess it's, if you want a certain configuration of the object or the and that you want to quickly be able to refer to without having to go back and set up that view again, that's how you would do that. And that's why you would use a different type of view. So view 1 in this case, I'm setting as my full section view, and view 2 as my half section view. And I can quickly switch between the two as I'm working. Okay, yeah, that would be good.
What's the correct answer for 24?
Okay, let's
Yeah, I got that wrong too.
Yeah, so I'd first put transition
Ah,
along,
yeah, this one's fun.
I did transition along the y-axis, rotation about the x and z.
No. It is, you're kind of correct, but your axes are wrong. So you can have translation or transition, should say translation. Translation about X and Z, rotation about Y.
No, it says choose which can once placed, what can you not do?
Oh, okay, my bad, my bad.
But on the highly confidential document, it only says rotation X and rotation Z. It doesn't have transition about the Y. Yeah.
Soon. Which of the following adjustments cannot be made to the block once the constraint is in place?
Yeah, so you can't
So
move it
you
up and down
cannot-
anymore.
You cannot rotate X or Z,
Correct. And you
And
shouldn't be
you
able to
cannot
transition Y,
trans-
right?
Y.
Yeah, I don't know why it's not on the answer document.
That was something I think we were looking at yesterday, Vanessa and I. And
Okay.
we have changed it in the actual thing.
Okay,
Here
all
you
right.
can see the answers are transition about Y is no
Yeah.
and rotation X and Z.
Yeah,
But we
I
just
would agree
haven't
to that.
changed it in the highly confidential answer document. We did change it on the test, so let's go back and
On number
Which number?
25, I didn't know what a presentation file was, but I know the other ones didn't show an exploded view, so I'll pick that one. But I don't
Yeah,
remember
that's it.
presentation file. I don't know. if
and
there
that's
was-
one of those things that we didn't. That's one of those things that I didn't go over with you guys, which you may or may not get to with your students. There's a video that talks about exploded views, and they're only in presentation files. The thing about a presentation file, for example, if I have this object here and I want to create a new presentation file, they are very time consuming. And it's down here, IPN, which is the presentation file. Because it's all about, you take apart and you set different views out over time. Say I take this and you set a view at this, and then you can move your time to set it in a different place, and so you can make it go out and come in. I've never done one of these. This is something that, once again, that I have very little experience with. I apologize for my lack of knowledge.
On 27, it says a feature
What?
that has dependent features. Does that mean other things are dependent upon it?
Right, right.
So if other things are dependent upon it, we couldn't suppress it, right?
You can.
I thought you
don't-
couldn't, I thought it was like a master feature that other
Right, right,
features
right.
were like.
So
dependent
remember how
upon-
I showed you in the pattern where you can suppress the copied ones, but not the original one?
But not
because
the
copied
original one,
ones
yeah.
Depend on the original one.
But it's saying you can in this master document, or unless I'm
Let-
reading the question
Let
wrong.
me look and see what number is that.
27, a feature that has dependent features cannot be suppressed. Does that mean trying to wrap my brain around the
I
question itself?
guess, okay, I think I'll have to look back at that. So I think, let's see, what number, it doesn't really give one, does it?
No, there's, I remember you, I don't know if I'm misinterpreting the question, but I know whenever we copied, the master
So-
one, we couldn't suppress.
In a pattern, you cannot, like in a pattern,
Yeah,
you can't. But, yeah, and I think that's only in a pattern that you
oh,
cannot
okay.
suppress the original. So if we look at features, let me see. trying to think of dependent, how I could show you a dependent feature.
I mean, I believe you. I understand.
Well, no, yeah, I agree. I just want to, I like to be able to give an example when I'm teaching, because they're going to ask me, some students are going to ask you,
So
you know.
let's say let's say that circle right there. Let's say we made other features like 2 times the size of that circle, 3 times the size of that circle. Could we suppress that circle then?
Yeah,
Okay, I guess that's what they're saying.
like if I did a sketch off of this surface here. And, you know, I don't know, let's cancel that. And I did like a concentric constraint. Well, that may not be the best idea, but, and then I extruded it. I know it's not fully constrained, but could I go ahead and then suppress the previous extrusion that has other features dependent upon it? Suppress features, and then it suppresses everything. Cancel. So yeah, so extrusion 2, can I suppress that? And it's going to tell me that it's going to give me an error. So I'm going to talk about that because I don't think that's correct. Let me find out about that.
Okay. Got about 2/3 of the answers correct.
I'm gonna do some research on that real quick.
So I thought suppressed on the last one. I thought suppressed. Maybe I didn't do much suppression, but I thought in the model viewer, if you suppress something, it just didn't show it. In the model viewer, is the model?
That's the thing over on the left, when you hit suppress.
I'm thinking that. I guess I was thinking of the actual model itself, but in the model viewer, yeah.
Over on the left, you suppress it, it grays it out, puts a line through it.
Yeah, that makes more sense to me. All right.
No, wait, which question are you talking about?
I just had it was more of a terminology issue than I was thinking in the model itself, but they're talking about like in the model viewer on the left, you know, that feature will be grayed out with a line through it. So in number 17,
Yeah, I'm ready to hear that.
share the sketch for the circular cutout. And
Hang on a second,
now
I'm
that
gonna
I'm
read
looking
something.
closer at it, it looks like that little circular cutout got shared to the other 2 surfaces, and then they wanted that surface area. I don't know how to do that.
Neither do I.
All right, which number are we talking about here?
17.
Shared sketches is the part.
Yeah, open shared sketches IPT.
Oh, okay, yeah. I know that. That one's, yeah, everybody has a question about that. That's making multiple, all right, so, and this is something that used to be a lot easier to do until they changed the way and I have a feeling this is going to be different on the actual test now, because they did a change to way the little pop-out menu looks. All right, so shared sketch. So what happens is open. So you can actually shared sketches. So remember we talked about doing multiple. The two ways you can use the same sketch for multiple extrusions is either by sharing it or just making it visible. So if we look at extrusion right there, if we take sketch number 6 and we share sketch, it just makes it visible. And I can't really tell you the difference between the
Oh, I
shared-
remember you talking about this. You said that you didn't know the difference between this and visibility.
Right, because when you share it, it basically achieves the same function as just making it visible.
Yeah, okay.
And since they're only asking you for this surface area,
Uh-huh.
at this point, you don't have to do everything they ask. I would just do a extrude. I would extrude there and there. You can go all the way through, but it depends on how they ask the question.
Through to
Cut
surface of
To
the,
there,
okay.
hit OK. Now this goes all the way through both of these, right?
It's not supposed to, but it's gonna get you the correct
It's
answer.
going to get you the right answer. However, there used to be, if I go back to edit the extrusion, there used to be a between here. So you have a from and a to that used to be together. But so you see you have from up here and then you have to down here. So what you can actually do is, let's go ahead and delete that extrusion, cancel. So we go extrude. We're going to select our faces. We're going to select cut. And we're going to go under from. We're going to there to there. All right. And then we're going to add another one. Select the profiles, and we're going to go from there to there. Cut. So this is how it used to be called between, and you used to have the tab and it would just say, you know, between, and you could say from and to, but they changed the tooltip. So now it looks more like that, from here to there. So you select, you don't actually have to do it right next to where the sketch is. So you could actually just say from this to this, and it'll only do the extrusion right there. Or from that surface to that surface, I'll do it right there. But that'll give you what you need. And then you get the surface area of that one right there, which would be tools, measure, area 2.721.
Sounds right.
Yep, that's correct. I'm still reading about suppressed features.
On number 15, how do you get the parameter name of the master hole?
Ah,
Because I thought
Yeah,
I had
there's
it,
that one too.
and I put D11.
Once again,
and it was
I
wrong.
think this is a misleading question. So these questions are published by Gmetrics. I don't like this question
When they
because
what are they
they
even
don't tell you
asking
what the
for?
master hole is.
Well, whenever I go to the sketch, I found the master hole because it was the only hole in this that it was patterned after. But I thought it was D11.
Well, it's easy to find if you, once you, let's see, what is that one called? Parameters?
So maybe I don't understand the question itself. That's what I'm thinking. I don't know.
I put D11 as well. So
Okay, so I'm not an idiot. All right, that's good to know.
I got it wrong too, though. So we didn't.
Yeah,
get
I know, but I mean, if with everything we with our knowledge at this level, like
No, no.
that's what we thought.
So to change the diameter of the
Because I went
master,
to the sketch, you don't really need to. I mean, you can't. I changed this diameter, but it really doesn't affect the name of the hole itself,
so
unless the hole gets named to something else. Is that what's happening?
this would be your master hole in the pattern right
Yes.
here.
Yep.
Okay. Yes.
And that's,
So I
Right
went
here.
to hole. Yes.
so we edit feature and you, like at this point, if you click on it,
See, it's D11.
well, hang on. If I change it to, what am I changing it to?
I'm changing it. All we're changing is the diameter.
8 point. Yeah, but what do they ask you to change it to? 8.165.
Yep.
Oh, sorry.
Well, you
Point. And right, I agree. Okay, so that's that. And they ask you, so if I go to manage
Manage parameter.
parameters, and I'm looking for that 8.165,
it's D14.
oh,
I see it now. 8.165 hole 1. So that's how you would do it?
yes. Correct. So that is,
How do you know that's the only one that's, I guess if you look at it, it's the only
because
one
when
that's
I
8 point-
change, so that's 8.165 whole one is, it's D14. And-
Okay.
Right. Why does it show up like that? Because on the sketch, it shows up as D11. I don't
Yeah, that
know.
hole shows it's D11.
But when I go to the sketch, but I'm not actually doing it from the sketch, I'm doing it from the feature, I guess is what you can say. If you, yeah. So that's why you change it so that you can see where it shows up, the change at.
Okay. And you
As
can
long-
only see it's changed in parameters?
Well. Hang on. It's still showing up as
8.
8. But if I go to the hole itself and edit feature, I change that to 8.165. Now,
But what did you
Hmm.
change to 8.165?
the width of the hole right here.
Okay, I see it. I think, yeah. I guess.
But why it doesn't update the sketch, I don't know. I'm wondering,
So if you'd have changed the master hole, shouldn't it have changed all holes? Because wouldn't all the rest of the holes be based off of that one hole?
well,
I don't know.
yes, it should, and that's what I'm looking at. I'm wondering why it didn't do that. But on the sketch,
Yeah, I went to the sketch and changed it there to 8 point whatever. I guess I should call that the driving hole, not the master hole. I'm old school where we used to have like master and slave, and I don't know that's not used anymore.
So let's look at, edit this feature. Um. Yeah, so if it shows up here, it did actually change all of the holes to 8.165. You just couldn't notice because for some reason that sketch was still reading.
Well, in the parameters, shouldn't all those holes now be showing 8.16?
Well, the holes, the parameter doesn't list.
Oh, I
the
see, it
division.
does. Oh, really? That's so, okay.
Well, because they're just copies of the original.
Yeah.
So your circular pattern tells you how many copies and how degrees, but they're all just copies of the original hole, which was 8.165.
Okay.
I'm just
And
not
now
understanding
D11 is no
why.
longer in your parameters? Oh, that's because you deleted it in your sketch,
Right. I deleted that in my
but you weren't
sketch.
supposed to necessarily delete it.
No, not necessarily, no. But I don't know why. I don't know why that was like that. Let me try something here if I can.
I also had lots of issues with number 21. I just had to give up on it.
I'm not gonna. $21.
Yeah.
Okay. So this one is, and this is something that the kids are gonna do too, is that you have to create the chamfers before you shell it.
The thing is, it's already shelled when you open it.
Huh?
Well,
Are
it's
you
it.
opening
Maybe I opened the wrong thing.
shell IPT? So if, and this is the other thing is, you have to, make sure you don't save the files because it'll overwrite
Oh,
the.
I must have opened the wrong thing. This would be much easier to do, yes. Because I was like, because I opened one that was just a box that was already shelled in the top, like, and I was like, well, this is already shelled. This is retarded. I was like, I almost need to extrude it and then do it. I must have opened the wrong thing. I don't know what I opened.
Yeah, so this is what you should look like at the beginning.
Yeah.
So you chamfer it and then shell it. You should be able to get that. All right.
No, what I'm forgetting. Oh. Oh,
It
okay.
kicked me out.
So when you open shell IPT, the bottom is shelled.
Huh?
Hang on a second.
Or I guess from the top.
You must be looking at a different file because the ones they told us to download, it's just a,
This is
You-
not, yeah, you're looking at, because this is, I just opened shell IPT.
Okay, I
And
just
there's
opened up Shell
nothing-
IPT2 and it's shelled.
So,
I think what's happening is for number 10, we had to open shell IPT and shell it because the same thing was
saved
happening to
it.
me. I still had it open.
I see. So
So,
when I got you.
yeah,
So
that's it.
I need to close it and then not save changes.
Correct.
Yep.
Oh, wow, that sucks.
Every
And
question I did, I closed it as soon as I got done with it because I didn't know if I was supposed to save it or not, and I just kept moving because
Well, I didn't close anything because I might have, like, if I opened it and I wanted to come back to it, I just, like, especially I just left it, I don't know. I didn't close anything. I
Yeah.
just kept opening
And that's
more.
not gonna happen on the actual test.
I
don't
didn't
think
want to
they-
take the time to close out everything. And what if I need to go back to one? I was like,
Got a point.
And what they'll tell, and what they do is, like whenever my kids take the test on a computer, they're gonna refresh and re-download the files every time. Just in case somebody changed something and saved a change or did something. So what I suggest is that if you're practicing, even if you don't think you made any changes, or, just gotta be very careful not to save any
well,
changes.
I didn't save anything, but like she said, it reopened the one, since the file was already open, it just,
Right,
it just continued from where I left off.
yeah.
Should we try practice test 2 if we're finished with practice test 1?
Sure.
Okay.
And so for the answer to the suppressed, you can suppress a feature that has dependent features. You can suppress it, but it will also suppress the dependent features. So I guess the question is you can suppress it, but it will also suppress any dependent features.
Gotcha.
Yeah, I'll be right back.
Danny, with practice test 2, use the exact same files as the ones from practice 1. Is that what I'm getting? You're muted.
It's not necessarily the same files, but we just combined all the files from practice 1 and practice 2 into one folder.
Okay, so whatever I downloaded to take practice test 1, use that same stuff for practice test 2.
Yes,
All right, thank you very much.
no problem. How are we doing, ladies? And gentlemen? Have we finished the practice test for the most part?
Yeah, I finished the first one. I'm working on the second one.
Good, good. Kathy, how you doing?
I'm good. It's all working out.
Okay.
Uh,
Asa?
Good.
All right. Well, if you guys got any questions, I'm just checking in. I'm still here.
is that all we need to do though? Or you-
Yeah. If you're done with that and you're good, we can just pick up on tomorrow though. Once you're done with
Okay.
all that and you're good to go, yeah, you can go ahead and sign off.
Okay.
I have a question about number 12 on the practice 2 test. Just because the picture is, I just want to make sure I'm looking at it right. The extrusions for the 2 new pieces, those are not supposed to be cut, right?
You're muted, Danny.
Thank you.
It's like the angle that it is, it's hard to tell if it's cut or not.
Yeah, I see what you're saying. Let's see, this is Sketch IPT share. Oh, Sketch IPT. It's the same one. So no, those are not supposed to be cut in this case. They're supposed to be, well, it's cut at the beginning.
The other two, it's at the top.
So
Yeah, I left the
it's
first
cut,
one
it's
cut.
cut there, but these 2 extrusions are not cuts on this. On this test, it's not cut. These
Okay.
are regular in between here and in between there. Yeah.
Okay, that's what I
Okay.
thought, but then the more I looked at it, my eyes were like tricking me, I guess.
No, that's it. You're right.
Okay.
All right. Any other questions, guys? Just keep working. It'll be fine. We'll finish it all up tomorrow. I'll be here till 1.
had to get pizza.